Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Today we will discuss a very important topic, that is isentropic efficiencies of steady flow devices. So if you look at these two diagrams, which is turbine, so it has two cases. One is ideal and one is actual. So what is the differences between ideal and actual? Okay, by definition, most steady flow devices actually operate under adiabatic condition, which is Q is equal to 0. And the ideal process for this device is isentropic process. Okay, so it means that the entropy at the inlet and the entropy at the outlet of the turbine is the same. S1 is equal to S2 and Q is equal to 0. Therefore, this is isentropic process. And usually, I represent isentropic process as S, subscript S, sorry. Okay, then what is the differences between ideal and actual? So for actual cases, the entropy at the inlet and the entropy at the outlet is not the same. S1 is not the same as S2. So the differences between ideal and actual will lead to this definition, that is isentropic efficiency. So isentropic efficiency means the deviation between actual process and ideal process. Next, we go to isentropic efficiency of a turbine. I sketch the schematic diagram of the turbine, and this is the inlet and this is the outlet. And we know that turbine has a power output. Okay, next we go to this diagram, enthalpy versus entropy. So P1 represent the pressure at the inlet and P2 represent the pressure at the outlet. So we have two pressure here, and if we can see, the enthalpy that enter at the inlet will represent as H1, and the enthalpy that moving out from the turbine is H2S. Okay, so what is the entropy? Entropy S1 is equal to entropy S2S. S means isentropic, which is ideal. Okay, this is for ideal cases. But for actual cases, we can see here that S1 is not the same as S2S. Okay, it is moving or it is converging from this point to this point. Okay, this we represent as 2A. A means actual. Okay, so the enthalpy here is H1 and enthalpy here is H2A. Alright, and we can see here this is work. The differences between enthalpy at state 1 and state 2 S is WS. WS means isentropic work. And the differences between enthalpy 1 with enthalpy 2A is represented with WA, which is actual turbine. Okay, the actual work is less than isentropy work. Therefore, efficiency are defined is to be less than 1, which is less than 100%. So, isentropic efficiency for the turbine is actual work of turbine divided by isentropic work of turbine, WA over WS. And from this graph, we can say that isentropic efficiency of the turbine is H1 minus H2A, so WA, work, actual, over H1 minus H2S for isentropic turbine work. So, if we use enthalpy, this is suitable for liquid or steam, and this value you can get from property table. What happens if the substance is in gas? Then we modify this equation Cp T1 minus T2A over Cp T1 minus T2S. Okay. That's all for isentropic efficiency of a turbine.